Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Hello and welcome to concept videos from SOFO Learning. We want to look at part 2 of the graphical solution modeling of linear equations. This video would review the three options or the three scenarios while we plot two linear equations. Alright, now before we go into the details of these three options, let's simply recap or review the standard form. What is the standard form of a linear equation? So there are two variables, x and y. Now we want to attach some coefficients, constants to these two variables. So let's say a is for x and b is for y. And we would attach a constant c along with it and equate all of that to 0. This forms the standard form of the linear equation. Now, I also want to point out to you that we have exponents for these variables as 1. This is not 2 or 3. So we are not dealing with x squared or y squared. And that's why when we plot this equation with real values, we're going to see a straight line. We already saw that in the previous video. Now, there are three fundamental options when we would plot a set of two linear equations. So let's look at the first option. So this is the x-axis, this is the y-axis, and let's say that this essentially is the plot of our equation 1. Now when we draw the second line, let's use a different color, right? The first possibility is that it will come exactly along this line. So the second equation comes on the same line as the first equation. That's the first possibility. The second possibility is that they are two parallel lines. Let me show you. This is, let's say, equation 1, and let's say this is equation 2. So they are far apart by the same distance everywhere, and therefore they are running in parallel. Now the third case is fairly straightforward. This is the x, this is the y axis, and the two lines essentially meet at one point. Now what is the significance of these three options? That's what we're going to review next. Now let's take a look closely at option 1, where both lines are the same. Now I have two equations, example equations right here. The first one is 3x minus y plus 4 equal to 0, and equation 2 is 6x minus 2y plus 8 equal to 0. Now on the first look, both of them look the same, look very different, but they are fundamentally the same equation. Why? Because you can see that 2 times equation 1 equal to equation 2, because 2 times 3 is 6, 2 times negative 1 is minus 2, and 2 times 4 is 8. So if you multiply all sides of this equation 1 times 2, you're going to get this equation. Alright? So therefore, ultimately, if you try this at home and try to plot this, you're going to get exactly the same line. Now, what is the most important point to understand here? Remember, every point is a solution. Now, this line, it's the same line for both equations, all right? Now, this line represents this equation, and the same very line represents this equation. So it contains an infinite amount of points, both line 1 and line 2, which are basically the same. So there is not one, not two, but an infinite set of solutions that satisfy both these equations. That's the critical point to understand here. If the equations are the same or their graph looks exactly the same line, then there are infinite solutions that satisfy both equations. Infinite solution. Now let's take a look at option 2, where we have two parallel lines representing equation 1 and equation 2. I have two example equations right here. Equation 1 is 3x minus y plus 4 equal to 0, and equation 2 is 6x, 2 times 3 is 6, 6x minus 2y. Notice it is multiplied by 2 on the y coefficient, plus 10 equal to 0. Now this is not proportional, but the other two are proportional. Now, what is so special about these two equations? You can try this at home, but you will get two parallel lines. But one way to think about it is, what happens when x is equal to 0, right? So if x was equal to 0 here, let's say x was equal to 0 here, equation 1 will say y is equal to 4. Now this term will cancel out and y is equal to 4. Now in the case of equation 2, you're going to get y is equal to 5, because 2y is equal to 10 and therefore y is equal to 5. You can see that the line crosses the y-axis at two different points. But otherwise, they are going to run parallelly. The way to understand it is in the proportion of the x and the y-axis. Let me show you. This ratio of the x coefficients, that is 3 by 6, and the y coefficient, that is minus 1 by minus 2, and the constant term 4 by 10. Now we know that these two are equal. These two items are equal, and this is not equal to the constant coefficient. This is basically half right here. Now why is this important? Because if the coefficient of x and the coefficient of y are proportional between these two equations, and the constant coefficient c, so this is about a, this is about b, and this is about c. So if a and the b are proportional between the two equations and c is not equal to that proportion, then you're going to get two parallel lines. Now there is no solution here that satisfies both equations. You are going to get a solution for equation 1 and equation 2 separately. There are infinite number, any point in here, but there is nothing common. Why? Because there is no common point between these two lines. They are always running in parallel. And the way to validate if they would run in parallel is to look at the proportion of A, B, and C. If the proportion of A and B are common, equal to, same, then they would run in parallel. So we need to look at the third option now. We have two equations, equation 1 and 2, as x minus y plus 4 equal to 0 and 6x minus y plus 10 equal to 0. Now if you try this at home, I'm sure you are going to see that these two equations would meet at one single point. But we can apply the test of the proportionality of the coefficients here as well. Let me show you. This coefficient is 1. So 1 by 6, negative 1 by negative 1, and 4 by 10. Now we know that none of these are equal. So this is the A coefficient, this is the B coefficient, this is the C coefficient. Now what is important is these two figures. The proportionality of A and B coefficients. If they are not equal, then the line progresses at different rates, and we are confident that they will meet at 1 point. So that's basically the test. So in this case, where the coefficients of A and B are not equal, proportion of the coefficient of A and B are not equal, we're going to get one single solution. So let's recap the three options. So the standard equation is A1x plus B1y plus C1 equal to 0. So this is the standard form first equation, and standard form second equation, let's say, is A2x plus B2y plus C2 equal to 0. Now our goal is to check the ratio of the x coefficient, the y coefficient, and the constant term. All right, so A1 by A2, B1 by B2, and C1 by C2. Now if all of them are equal, all right, this case is case 1. Case 1, all equal. Now we will get same line, infinite solution. All right, now if the proportion of coefficient A and B, A1 by A2 and B1 by B2 are equal, but they are not equal to C1 by C2, then we have case 2. A equal to B not equal to C. Then we get parallel lines. And no solution, no common solution, because the line would not meet. Now if this portion A and B are not equal, it doesn't matter whether the C portion is equal or not, but if A1 by A2 is not equal to B1 by B2, we're going to get case 3. Now in case 3, we have A not equal to B, and we have a single solution to both equations. Thank you so much.